Hi everyone, today we are going to discuss about transceiver design considerations in wireless sensor network. Transceiver means transmitter and receiver. The combination of transmitter and receiver is called transceiver. Each and every node having transceiver to transmit and receive the information from the adjacent nodes. Transceiver design considerations in wireless sensor network. Some of the major points influencing the design of the transceiver. The first one is low power consumption. So we have to design a transceiver. It must consume very less power. So then only the lifetime of the node will increase. So otherwise it will dead as soon as possible. So the second point representing another consequence. So if you are increasing the transmitting power, the coverage distance will increase. If you are more focusing on the transmitting power, if you are reducing the transmitting power level, obviously the range of the coverage will reduce. The third point representing the most hardware should be switched off or operated in a low power standby mode most of the time. In any application in the wireless sensor network, majority of the application, so the sensors nodes activation frequency will be very less. So the frequency of the occurrence of the event will be very less in the wireless sensor network. For example, in the agriculture field, if you are deploying the node for the purpose of moisture monitoring, so if the moisture level reducing from the threshold level, very rarely occurring event. Okay, in that particular situation, if the node is continuously activated for the entire 24 hours, it will drain up the entire energy. So that's why while designing the transceiver, we have to activate that particular node whenever the event is occurring. The remaining time, the node will be at a sleep mode. So the fourth point representing, so the communication between one node to another node in terms of 10 kilobits per second to 100 kilobits per second is the requirement. The fifth point representing low implementation complexity and cost. Obviously, we are expecting the low complexity and cost of the transceiver. The final one is we are considering the low degree of mobility in the node. Okay. So next we are going to discuss about major four different design considerations in wireless sensor network we are going to discuss now. The four different scenarios are: one is energy usage profile, the second one is choice of modulation, the third one is dynamic modulation scaling, the fourth one is antenna consideration. So the two pictures available in this particular slide, the first picture representing the real wireless sensor node, the second one is the architecture of wireless sensor node. Out of this architecture, so the blue color block representing combination of transmitter and receiver. So the combining together only we are representing as transceiver design or transceiver block. So this block is responsible to transmit the packet from one node to another node. First consideration is energy usage profile. In this particular block diagram, the last dotted line block representing transceiver unit. The transceiver unit consists of RF front end, ADC, DAC, demodulator, modulator, decoder and encoder. So these are the blocks available in the transceiver unit. Out of these four blocks, the major power consumed by the RF front end. So the first point representing the overall transceiver consumes much more energy than is actually radiated. So for example, a transceiver working at frequency beyond 1 gigahertz takes 10 to 100 milliwatt of power to radiate just 1 milliwatt. Similar manner, another one example representing 2.5 gigahertz CMOS transceiver for a radiated power of 0 dBm. The transmitter uses actually 32 milliwatt, whereas the receiver uses even more 38 milliwatt. So actually radiated power is very less, but consumed power is very high as per the energy profile. The second key idea to save the transceiver power is, so keep the transceiver in the sleep mode instead of ideal mode, because ideal mode consuming maximum power compared to sleep mode. So in that particular situation, another one problem will arise whenever whenever the node goes to sleep mode. We have to wake up the node and activate, then finally detecting the one particular event. So in this particular process itself consuming the power and wake up time. So for example, in mu amps, one transceiver needs a setup time of 466 milliseconds to wake up from sleep mode to ideal mode, and also the power consumption of 58 milliwatt from ideal mode to sleep mode to ideal mode. So that's why depends on the traffic pattern and behavior of the node, MAC layer protocol to schedule the transceiver operational state properly. So based on the expectation of the application, we have to decide the sleep mode and ideal mode, the corresponding time duration. The third key idea to save the power in the transceiver is, as per the transceiver used to transmit the bits. So each and every bit will be transmitted after computing lot of instructions in the microprocessor. So here that overall computational power requirement is less compared with communication. So here we can see one particular transceiver, it will execute 1500 to 2700 instruction to transmit one bit. Similar manner, the second transceiver also they are representing 200 instruction to 2900 instruction per bit. So here the overall conclusion is, your communication cost or power requirement is more compared to computational power requirement. Choice of modulation also plays a major role in design of transceiver design. So here the choice of modulation will be depends upon the data rate, symbol rate and implementation complexity, the relationship between radiated power and the target bit error rate, and the expected channel characteristics. Based on this particular parameters, we have to select a proper modulation scheme. So generally in the transceiver designing, the two types of measurements is more important. One is symbol rate, another one is data rate. So based on the, if you are increasing the symbol rate, the power consumption is more compared with your data rate. So that's why we are more focusing on the symbol rate. So for example, in the QPSK modulation or your differential PSK modulation, so the how many number of bits are representing as one symbol, that will decide your corresponding data rate. Okay, so in our 8QAM modulation, for example, 3 bits are considered as one symbol. If you are transmitting one symbol, obviously at a time you are transmitting 3 bits. So that's why overall power consumption depends upon your symbol rate. So that's why we have to keep the symbol rate is less, at the same time data rate must be very higher. So to select the proper modulation, okay, we have to always focus on M or a modulation scheme to save maximum power and also achieve maximum data rate. The next one is dynamic modulation scaling. It is interesting to consider the method to adopt the modulation scheme to the current situation. Such an approach called dynamic modulation scaling. In particularly one example, they are representing M array QAM. The targeting bit error rate is 10 to the power 5. So a model has been developed that uses the symbol rate of B and M representing number of possible symbols. Here clearly the bit delay and energy per bit, so it will decrease based on increasing your symbol rate and the number of possible symbols m. So the overall transceiver, the energy consumption based on the modulation decreases if you are increasing the symbol rate and also increasing the number of possible symbols. The fourth consideration of transceiver design is antenna consideration. In this antenna consideration, the two pictures are available. The second picture representing underground sensors are available. The first picture representing your on-ground sensors are available. Based on this particular two different scenario, we have to design a proper antenna to achieve very good quality of communication between node to sink. In the antenna consideration, always we are thinking about we have to design a smaller size of antenna and also minimum number of antennas in a node. So the antenna is much smaller than the carrier wavelength. It is hard to achieve a good antenna efficiency. So then we have to satisfy always H is equal to lambda by 4. So if you are not satisfied that particular condition, what will happen? The efficiency of the antenna will reduce. So that's why if you are selecting unfriendly size of antenna, it demands more transmitting power. So obviously the energy consumption will increase because of the unfriendly size of the antenna selection. So at the same time, the another one problem in the antenna designing, some nodes are requires more than one antenna. In that particular situation, within the board, if you are going to place more than one antenna, the distance between one antenna to another antenna, the minimum requirement is 5 to 6 centimeter. We have to satisfy that particular distance between one antenna to another antenna. So another one problem is antenna must not project from the case of the node. So to avoid the possible damage of antenna, we have to place inside the case of the node. The antenna must place inside the case of the node. So with this particular restriction, in general, limit the achievable quality and characteristics of the antenna for a wireless sensor network. So while designing an antenna, we have to consider all those points. So then we have to design a optimum transceiver for any node. Thank you for watching this video. We will meet again with another one topic in wireless sensor network.